السلام عليكم ورحمة الله وبركاته. My dear students, in course Operating Agricultural Engineering Units, this will be our first lecture. It will be about some engineering basics we need in our course. The important units, especially those we will use in this course, we will focus on them. We have here length, the distance between 2 points, measured by meter, or we will use meter as a unit. Sometimes we can use inch, centimeter, mass with kilogram. These of course are the primary or the fundamental units. Time per second, minutes, hour, temperature, Celsius, Kelvin. The Kelvin equal Celsius plus 273 ampere, candle, mole. Area is here. The area is unit squares equal in measure to the surface. So the area is the unit of the unit squares equal in measure to the surface. We will use inch square, feet square, mile square, meter square, and in Egypt we use faddan or fed. The faddan equal 4,200 square meter or meter square. Of course, this is derived unit. Another derived unit is volume. Volume can be defined as the amount of space occupied by a three-dimensional figure. Of course, the famous unit here would be the liter, as we mentioned before. Liter. It shows the blue liter or cubic meter. So cubic meter and liter are the famous units for volume. Temperature is the degree of hotness or coldness of an object. The temperature is the degree of hotness, how hot is the subject or the object, or how cold is the subject. We can use Kelvin, Celsius, Rankine, Fahrenheit. Those are the most famous units. Another derived unit is weight. The weight equal mass times gravity, m times g. So it's a function of both mass and gravity. That's why the weight, like the figure here, the weight on Earth or in the moon is 1/6 from the weight on the Earth. So if a female weight was 150 Libra force, it will be equal 25 Libra force on the moon. Why? Because as we mentioned before, it's function of the gravity. The famous units for weight is Newton or ounce, pound, ton, kilogram force. We can use, of course, kilogram force, kgf, or Libra, lb, F. So Libra and kilogram are mass unit. If we add F, it will be Libra force or kilogram force for weight or for the force. Here it's a comparison between the Newton and kilogram force and Libra force. Another derived unit is force. Force is action which cause or tend to cause motion. Force equal time mass times acceleration. Acceleration and gravity have the same unit, meter over square second. So the force can have the same units as the weight, but weight is mass times gravity, which is 9.81 meter over square second, while force equal mass times acceleration. We have pressure here. Pressure equal force time over area, force over area, or the amount of force exerted over a given area. The pressure is the amount of force exerted over a given area. Force over area, F over A. The units would be force by Newton, area by square meter. It would be called Pascal. Another famous unit for pressure is bar. So bar or BSI for pound per square inch. Pound lbf over square inch in square. So we have Pascal, which is Newton over square meter, and we have PSI, pound per square inch, Libra force on the pound over inch square, and we have the bar. The bar, kilogram, the bar equal kilogram force over centimeter square or square centimeter. So the kilogram force over square centimeter bar, pound per square inch PSI, and Newton over square meter Pascal. Energy and work and torque. Energy, work, torque, all of them have the same unit, which is the famous unit is joule or Newton meter. Newton times meter. So the famous unit for energy, work, torque is Newton meter or it's equal joule. Energy have many forms. We have potential energy, we have dynamic energy, we have work, we have heat energy, and so on. Every kind of energy have its formula. For example, the potential energy equal PE, potential energy equal m times g times z, mass, gravity, z the elevation, or the height of the body. uh, the kinetic energy equal half time m time v square, v for velocity. The work here equal force time distance. So if we want to move a body, if we have a body and this body weight 1 Newton, for example, and we want to move this body for 1 meter, a distance from this place to this place with distance 1 meter. If we want to move this body, which weighs 1 Newton, from this location to this location, from here to here, so the work needed will be the force, which 1 Newton, times distance, which equals 1 meter. Newton meter is equal joule. So we need joule to move a body, weight Newton, distance 1 meter. Another torque is another term, also equal force time distance, but in this case the torque is the application of force through a lever arm, or it's the force that causes or tend to cause a twisting or a rotary movement. So the torque have fixed or a lever arm, and we will use a force here at this point equal 1 Newton. In this example, this is a free end and this is fixed end. If we act with force in this location, it will rotate the arm. So in this case, it's not moving from a place to a place like the work. It will rotate or twist, for example, like it can be twisted like this. So in this case, it's called torque. Torque equal force. In this case, we don't say times distance. It's the force arm here. So the force arm, the arm is the distance between the place which the force act to the center of rotation. The distance between center of rotation or rotation distance to the force application. In this case, this called the force arm or the arm. So the torque equal force times arm. Of course, it's Newton times meter or joule as work or as the energy. Another famous units for energy is BTU or British Thermal Unit. BTU or British Thermal Unit. British Thermal Unit is the energy required to raise the temperature of 1 liter of water, at 68 Fahrenheit by 1 Fahrenheit. So to raise the temperature of lib mass of water to 1 Fahrenheit, we need 1 British thermal unit or 1 BTU. Another famous unit is the calorie, and the calorie is the energy required to raise 1 gram of water by 1 Celsius. So 1 gram raised by 1 Celsius calorie. 1 lib raised by 1 Fahrenheit British thermal unit. The British thermal unit equal 1055 joule, or the 1 British thermal unit equal 1.055 kilojoule. We can say the 1 British thermal unit equal 1 kilojoule. To illustrate the British thermal unit or the kilojoule, we can, in this figure, a typical match yield about 1 British thermal unit or 1 kilojoule of energy if completely burned. So if we let this match completely burned, the heat energy exit from this combustion process or from this burning match will be equal about 1 British thermal unit or 1 kilojoule. The most important term in this part, of course, will be the power. Power. The power is the rate of doing work. So it's work over time. The rate of doing work. And as we mentioned before, work is the result of force acting or moving through a distance. As we mentioned before, work, the equal force, time, distance. Okay. As we said before, we have many forms of energy, potential energy, kinetic energy, heat energy, chemical energy, nuclear energy, and so on. So we have many forms of power. We have a hydraulic power. Hydraulic power equal discharge time pressure. So if we have a pump and this pump and we want to calculate how much power need to run this pump, we need to know the pump discharge and the pressure. Discharge times pressure will give us the hydraulic power. Of course, it will be by watt or horsepower. Watt or horsepower. Watt and horsepower and the kilowatt are the most famous power units. We have two kinds of mechanical power. We have mechanical power linear movement. If we have a tractor moving while doing work, so if the body or the object is moving in a linear movement, in this case the mechanical power will be work over time. Work rates of course over mean time. So work over time will give us a mechanical power. Work equal force time distance. Force time distance over time. Distance over time equal speed or velocity. The velocity is the change, distance change, or the distance over time. So the mechanical power will be force time velocity. So we can use work over time, velocity time displacement over time, or velocity force time velocity. If the body is rotating, so mechanical power, but in this case, the rotation, as we mentioned before in the torque, if we have a lever arm and this arm will rotate a fan or something, in this case, force arm, and as we mentioned before, we have torque equal force times arm. The mechanical power in this case will be 2 pi n t, 2 pi nt, where t for torque, which equal force time arm length, the length of the arm or arm length, n the rotational speed. This arm rotate one rotation per second or two or 100 or 1000. So the rotational speed will be n. This is the hydraulic and the two types of mechanical power. Of course, we have electric power, which will be current, time, voltage, but we will focus on the hydraulic and mechanical in this part. What is a conversion factor and how we use it? The conversion factor easily is a ratio, and this ratio expressed as a fraction. So it's a ratio expressed as a fraction. This fraction should equal the unity or equal 1. Uh, we use the conversion factor to convert units. How this conversion happened? We multiply our original measurements by the conversion factor. So we multiply the original units time or by the conversion factor to get the new units or to get the same measurements expressed in a new unit. So the conversion factor is a ratio or a fraction which represent a relationship between two different units. A conversion factor is always equal unity, and this is important. Example, convert 150 liter per minute to meter per square per 3 over second. So we want to convert from liter per minute to cubic meter per second. First of all, we will write down the number or the value and forward by its unit. Then we will go to the conversion table or the conversion factor table to search uh, how the relation between liter and cubic meter and minute to second. Of course, we know that the 1 minute equal 60 seconds. What about the cubic meter and liter? Uh, we go to the conversion factor, letter M, and we will find that the 1 cubic meter equal 1000 liter. After that, we need to write the conversion factor as a fraction between vertical bars. We will put the conversion factor between vertical bars. Okay, so this relationship or this relation 1 minute equals 60 seconds can be written by 1 meter over 60 seconds or 60 seconds over 1 meter. Also, the cubic meter equal 1000 liter, so 1 cubic meter over 1000 or 1000 over 1 cubic meter. We can put them down in this way or that way. Then we want to cancel minute, so the minute should be up. So the 1 minute equals 60 seconds to cancel minute with minute. What about liter and cubic meter? The liter is up. To cancel liter, it have to be down. So the liter will be down and the cubic meter will be up. To cancel the liter with liter. Then we have 150 times 1 times 1 cubic meter over 60 seconds times 1000. 60 times 1000 seconds. We use our calculation, our calculator. Then we have it, the answer will be the value 0.0025, and every number should be followed by its unit, the cubic meter over second. Another example, we want to convert 21.5 inches to centimeters. As we said before, we will go to the conversion factor table and we will find that the 1 inch equal 2.54 centimeter. So we will make the fraction between vertical bars 1 inch over 2.54 centimeter or vice versa. Here's the 21.5 inches equal times. We want to cancel the inch and the inch is up, so inch will be down. So the 1 inch over 2.54 centimeter. To cancel the inch with inch, then we have 21.5 times 2.45, 54 centimeter.